So in this talk, we're going to do pandas versus koalas, the ultimate showdown. So sadly, we won't be talking about this. We're not going to be talking about who is cuter, pandas or koalas. But we are going to be talking about data science at scale, which is just as good, right? So just what we're going to talk about today, I'm going to just do a quick introduction to doing data science at scale, which I'm very sure that most of you are very familiar with. A few words on pandas. Again, I'm sure this room knows way more about pandas than even I do, but I just like to get everyone level set and on the same page. Then we're going to talk a little bit about what is Apache Spark. Again, this room is probably very familiar with it, but again, let's get us all on the same page. And then we'll transition into what is Koalas. Then I'm going to do a demo for you, and then we're going to do the ultimate showdown and which is better, pandas or koalas. So a little bit about me. So like it was said, I'm a solutions architect at Databricks. So I have worked at a variety of companies in the Bay Area since I got my master's in 2012 in computer science. And I got that at Santa Clara University, which is in the Bay Area. And I also have a BS in biology from the University of Washington in Seattle. And I'm one of the very few people that you'll actually meet that lives in California and was born in California. So, and my folks were born in California as well, so I'm pretty rare. So I've worked, like I said, variety of companies. I worked at a small startup that was an enterprise version of Apache Trifodian, which was a SQL on Hadoop solution. And before Hadoop died, you needed a way to be able to query it with SQL, because that's what most people have the most familiarity with. And so that's what Apache Trifodian was, or is. So I've worked on 5 different distributed systems in my time as a software engineer and solutions architect. I never thought that that would be my passion, would be distributed systems, but nevertheless, here we are, and it is. Also, from time to time, I meet someone who says, "You're my teacher." And I'm so confused by what they mean. And that's because I was an instructor for a Udacity course on data engineering, a nanodegree program that they had. And so every once in a while, I meet someone who took that nanodegree program, and they recognize me. Okay. So again, let's have a little bit of fun. Let's have a contest. So if you want to win this adorable stuffed koala, now there's only one. There's only one because that's all I could fit in my bag to come here. So create a great live tweet from this talk. You can tag me, that's my Twitter handle. You can use the hashtag PyData NYC koalas, or you can just tag me, that's probably plenty, or PySpark. And then stick around after the talk. I'm going to go through the Twitter tweets. I'm going to pick my favorite one, and then you get the koala. Okay, so let's get to the nitty-gritty here. So why should a data scientist care about scale? Right? So we all know that we're getting huge amounts of data from a variety of sources. Clickstream data, customer data, IoT data, video and speech data, and this isn't going away. This is only growing more and more every day, every year. But as a data scientist who may be working on building models on your laptop or a small server, you say everything is working just fine, right? I'm able to accomplish my, my SLAs, my tasks, whatever my business needs, I'm able to do that. So you're probably building models on a subset of your data. And you're saying, okay, that's working just fine. So why should I care about scaling up? Why do I care about big data? So there was actually a Google paper in 2009 that basically said that when you have a large data set, so a big data set, and you use simple algorithm, you actually get better models. So this was the white paper, The Reasonable Effectiveness of Data, and they essentially proved that. So you can actually have your large data set that you're getting from all this variety of sources and build simple models on top of those, and you're actually going to get better results. So that's really why you should care about scale. Okay, so now we have that frame of mind, but let's kind of go backwards. And what is Pandas, right? So Pandas, it was authored by Wes McKinley in 2008, and it's that standard Python tool for data manipulation and analysis, right? Probably many of you are using it every day. So it can deal with a lot of different situations, including basic statistical analysis, handling missing data, time series, categorical variables, strings, right? That's what Pandas was built for. But why, okay, so that we know what it is, but why would you use it, right? So it's really easy to start with Pandas. A lot of the time, it's the default choice for teaching. It's super easy to install. I mean, you can get started with it just on your laptop. Yep. Sorry about that. There we are. So it's super easy to just get started on your laptop. It's easy to write tests, right? You can just use all Python. That's very simple. There's a huge community around it. Again, like all of you will probably, if I asked, how many of you use Pandas? Everyone will raise their hand, right? There's a ton of APIs for data manipulation. It's tightly integrated with different visualization tools, machine learning tools. So that's kind of why people are using Pandas. Okay, so we've kind of talked about Pandas, we talked about scale, so let's talk about Spark, right? So Apache Spark, right, an open source platform, and it's really the de facto for unified analytics engine for large scale data processing. So if you're doing big data, you're doing large scale data processing, you're probably using Apache Spark in one of its variety of forms, right? Maybe pure open source, maybe something like Databricks, maybe something like AWS EMR. So it's really good for streaming, doing ETL, our data engineers out there, and also with machine learning. So PySpark is the API for Python for Apache Spark, and it's very popular, especially as a solutions architect at Databricks. I mean, a lot of people, data engineers, data scientists who use Apache Spark, and I would say, I don't want to give a figure, but majority of it's using Python. But there's also support for Scala, R, and SQL. Okay, so let's kind of break it down here just a little bit. Pandas versus Apache Spark. So Pandas is really good for like a single machine workload, right? And it's really great for small amounts of data. While Apache Spark is the standard, the de facto standard for distributed workloads with big data. So that's kind of the two differences between those. So what's wrong with PySpark? Okay, so we talked about how great Apache Spark is. Why can't you just, especially all of us who know Python and love Python, why can't you just use PySpark? So what's wrong with it? Well, nothing at all. There's nothing wrong with PySpark. PySpark is very popular. But the integration isn't seamless. You can't take the code the Python code that you wrote utilizing Pandas, you can have that and then run it on Apache Spark. It's not going to work that way. They both have data frames, and let's dig into that a little bit. So there's a Pandas data frame versus a Spark data frame. So a Pandas data frame, and these are just two very small examples I just wanted to show here. So for example, a Pandas data frame, the mutability, it's mutable. Or a Spark data frame, it's immutable. So if I want to make a change in my Spark data frame, I actually have to create a new data frame to reflect that change. With Pandas, you don't have to do that. Now here's just an example of some code of the value count. So if I'm trying to do a value count with Pandas, you see it's a dot value counts. Very simple. If you're trying to do that with PySpark, now while that's not incredibly complicated, it's much more complicated than just using Pandas. And again, if you wanted to just be able to, oh, I wrote my code here on my laptop, I'm happy with it, I want to transfer it over and run it in production on PySpark, you're not going to be able to do it because it's not the same code. So here's just another example of that as well. So here's, I think, one of the greatest examples is showing how to read a CSV. So with Pandas, let's see if this works here. So Pandas, you can see read CSV, you just put in the CSV file, the path to it, it reads it in. With PySpark, again, not that complicated, it's pretty powerful, works really well, but you see you have quite a few options that you have to add in. You have to infer the schema, you have to set that to true, you have to let it know if there's a header, etc. And then just here are some other examples of the differences between Pandas and PySpark. Okay, so that gets us to what we're all here today to actually learn about, which is what is Koalas. So Koalas was announced in April 2019, so this year. It is a pure open source Python library that was created at Databricks and then donated out to open source. So it aims at providing the Pandas API on top of Apache Spark. So it's going to unify the two ecosystems with a familiar API. So you can have really a seamless transition between small data and large data. So let's talk about what's good about Koalas. So you can be immediately productive with Spark. So you may already have that code. Like we said, many of us learn how to do data science utilizing Pandas. That's what's taught in school. So then I can come over to Apache Spark, which maybe I haven't run before, maybe because I haven't had the ability to have a cluster running, because most of us, clusters are expensive, and most of us have our laptops already. Right, so there's no learning curve. So you can have a single code base that works both with Pandas and Apache Spark. So you can just have one set of tests. You could develop on that small data set on your laptop, like we talked about, and then you can utilize the power of PySpark for production and running it on a large data set. Again, to get those good insights that we talked about, why you'd want to run your algorithms at scale. So here's just an example of showing the difference between pandas and koalas. So you can see, other than the import statement, and I'll show you more of this in the demo as well. So import pandas as PD. In this case, it'll be import databricks.koalas as KS. Now, I don't want anyone to be kind of afraid here when you see databricks.koalas. Like I said, it was developed at Databricks, but it's not proprietary to Databricks. It's totally open source. You're going to see here in the demo, and you can see actually where I took the notebook and I put it online as a Jupyter file, Jupyter notebook. So it's totally open source. You could totally get this all installed, even on your laptop, wherever you're running Apache Spark. It's just a Python library, that's all. But just more on, you can see that the .read CSV is exactly the same. So here's just a word on the Koalas architecture. So it's really just showing you, let's see, do I have my, yeah. So Koalas, like we said, is going to be unifying the two. So as you can kind of see here, so you have Spark, right? So Spark in its architecture, you have SQL, you have your data frames APIs, you have the Catalyst optimization engine, then you have your data sources, and then the Spark core, right? And then off to the side you have pandas, and there's no lines between the two, right? So Koalas is really bridging that gap. So it's an abstraction layer on top of Spark. So another thing, just to make sure everyone's aware, when you are running those commands in Koalas, you are running a distributed job on Apache Spark. Okay, so now it's time for the demo. Okay. So like I said before, oh, my cluster shut off. Let's start it. So in this particular case, for my demo, you see me, I'm using actually the Databricks workspace. This is where I have a demo environment set up. Now, you'll see this, like I said, you can also run this all on your own with either like the Databricks Community Edition, which actually is nice because it gives you you have a free single node that you can just spin up and use and start working with this. Kind of defeats the purpose a little bit of using Koalas, which is needed for scale. But again, if you just want to experiment with it, you can. But in my case, so I have an 8-node cluster here, Apache Spark cluster that I'm going to utilize. But nothing here in the demo is utilizing anything that's proprietary to Databricks or anything like that. It's just, this is where I have a cluster, so that's what I'm using. Okay, so Pandas versus Koalas, the ultimate showdown. So in this demo, I'm going to show you some of the basics around Koalas, and then why we should use Koalas for big data with an example. So again, like you saw before, we want to import Koalas. Now again, in this particular cluster, what I have to do, like if you were setting it up yourself, I actually, on my cluster, once it gets, I provision it, I actually have to go and install the library. So I'm not going to show you how to do that here, but what I need to do is actually install that library on the cluster, which I've already done in this case. So I'm going to go ahead and import it. I'm also going to import pandas. And so I just want to show you here in this first cell. So we're going to kind of do some basic things to these first couple cells, and then we'll do some things that are more advanced. So I'm just creating a Koalas data frame by passing a dictionary of objects that can be converted to like a series like. So you just see that I have A, B, and C as my column headers, and then just a variety of dictionary objects from there. And then I'm just displaying it. So you can just see how it's something very familiar that you're used to with pandas that you can see being done with Koalas. And next I'm just showing you how we can actually create a pandas data frame. You're all very aware of this. So I don't need to really go into that. We're just doing like a date range and then creating like a random set of numbers in a data frame. And so why I'm doing that is because I can actually now take that pandas data frame that I just created and easily convert it to a Koalas data frame. So you see KS from pandas, and then that's my pandas data frame that we just created here. And then I'm going to create this data frame that I'm calling KDF. And so if I do a type on that KDF data frame, you'll see that it is a Koalas data frame. But if I print it out, you see it looks exactly the same, and it will behave the same way as a pandas data frame. So I can do the same familiar operations that I'm used to with pandas. So I can take a head and get a few rows. I can describe on that Koalas data frame and get a summary statistics of my data. So like count, mean, again, all the things that you're familiar with. And this is something that was important for me to show you here, getting data in and out via CSV. So now you can see, like I showed you earlier in the slides, you could do the exact same thing that you're used to with pandas. Very simple. Because it's all well and good to show how you can create a data frame, you know, from a few rows, right? A few lines, 1, 2, 3. But this is where we're really going to be getting data coming in. Okay, so now I want to actually demo something for you that is a little bit more advanced here. So let's do some natural science. So like I said, I do have an undergrad in biology. So we want to dig a little deeper into a real data set. So we're going to be looking at a data set containing the occurrence of flora and fauna species in the Netherlands, that's where the data set comes from, on a 5 by 5 kilometer scale. So this is what's called biodiversity. Actually, I did a very similar lab to this when I was in my undergrad. So what you do is you take this, it wasn't 5 by 5, and because that's actually quite large. Ours was, I think, that's 1 foot by 1 foot because it was just a lab for school. But what you do is you go out to the lab, or to the plot, you have your notebook, and you document every single unique species and the number of that unique species within that plot. And it helps you to measure the biodiversity in that particular plot. So this data was grabbed from observation.org, and it's nature data from the Netherlands. So first thing we're going to do is we're going to load the data, and then we're going to do some exploration. So since my cluster is up and running, hooray, I can uncomment this code. So I'm going to load this full data set using pandas. So if I run this, which I'm really just running this for dramatic effect, because this is going to take probably around 10 minutes, and it might actually, if it does exceed after 10 minutes, it also may not, and we may get an out of memory error. So this is I want to get my full data set here, right? All my CSV files. So it's going to take a long time, so let's go ahead and cancel that. So instead, if I'm going to load a sample of my data set using pandas. So I'm just going to get one of those CSV files, and I already ran this, so I won't run it again. Won't tempt the demo gods here. So I already ran this, now it's just on one CSV file. Okay, that was successful, great. I think we can see the time here. So here's just taking a sample of the data so we can just take a look at it. So you see it took around 5 seconds to load that one CSV file. So right, we've taken a subset of our data now. So it contains around 269,000 rows and 50 columns. So if I take the shape, that's where I can get those counts. So instead, what I want to do with Koalas is I can actually load the full data set. So as you can see, I just have to do a few things to ignore some warnings here and let it know that we want to do this. We want to get this in as a distributed data set. So I'm going to read in my CSV. I'm going to read in the large CSV file. Then I'm going to just, again, take a look at it, which I've done. And we can see the time here. So this took around 2 minutes to load in. So instead of the 10 minutes it would have taken with pandas and not been distributed because it just would have been on one single node, this is now a distributed data set across my 8-node cluster, and it took about 2 minutes to load. And in this case, we have 26 million rows and, again, 50 columns. And I did that, again, on this Koala data frame by taking the shape, so I can get that. So I can also just, as we're familiar with pandas, I can do a dot columns, and I can see all the column names. So, and if we kind of scroll back up here, I can kind of show you what we see here. So we see an ID, a data set key, occurrence key, so just a lot of keys, the kingdom, the phylum, the class, so Amelia, and the order, the family, genus, species, etc. And then just more information, the scientific name, etc., about what they saw in this 5 by 5 plot. Okay. So then we can actually do a value count like we were looking at earlier in the slides. And we can see that we have the most items that we have in this data set is from the Amelia. So we're seeing animals. And then after that, we're seeing plants, fungi, protozoa, chromista, and bacteria. And so that's just doing a value count by the column of kingdom. So we can do a little bit of data visualization using Pandas. So in this particular case, I'm using, again, that downsampled smaller data set. So if I make a bar chart on the kingdoms column using the Pandas data frame. Okay, so it looks like what we saw, right? Mostly it was animals and then plants and then small amount of fungi, and then it just kind of tapers off from there. Okay, but let's do some data visualization using koalas. So this is our full data set, right? So here, we're seeing a slightly different bar chart, right? We still see our animals as being the most in that 5x5 plot, then the plants and the fungus, but we see on our x-axis, we've now added bacteria. Now we can't see how, because it's just a rough bar chart, right? We don't have the scale here. We can't see how many there are, but we see that they are available. They are in this 5x5 plot. With our pandas, we don't see that at all. So that's kind of like, that's just take a note, right? When you have a larger data set, you're going to get more complete answers about what is there in your data set. If you had just used your pandas and you had developed all of your models around that, you may think about a customer segment within your data set for your companies, right? You may have missed a completely unique customer that you could have been modeling for, and you wouldn't even have known it was there. But with your full data set, you would. Okay, so then I just did this one last thing just for fun. So did these folks find any koalas or pandas within those 5x5 plots? So you can see here, again, it should be code that you're very used to with doing search with pandas. So I'm just looking for the location. We're going to look on the species. And then this is actually, I'm not even going to try to say it, but this is the scientific name. I Googled it for a koala. And this is the scientific species name for a panda bear. And so if I run that search and I do a display, you'll see that nothing returns, unfortunately. But also it makes sense because this is just for fun. This is a data set taken in the Netherlands. So it's unlikely in the Netherlands on a 5x5 plot they're going to find a koala or a panda bear. But we couldn't find these adorable bears, but that's okay. Okay, so that wraps up the demo there. I hope that you could see how it's very similar to using pandas, and also the whole point of why you would want to use koalas versus pandas. So let's come back. All right, so the ultimate showdown. Who is the winner? And the winner is you, right? The community, data scientists, data engineers, now you have more tools to be productive and successful. So think of koalas for scale and pandas for doing learning and small data exploration. So neither one is better than the other. They're just good for the tasks that you're going to do and that you'll need to do. So just a few words about koalas. So it's quickly gaining a lot of traction in the community. So the developer community is actually doing bi-weekly releases on it. So there's been greater than 500 merges and patches submitted since its announcement, and that was just in April. So there's a really strong community already gathering around this open source project. So there's already 20 significant contributors, and I think last I checked, maybe it was 5 that were completely outside of Databricks. Just people who have saw, okay, this is an amazing open source project, I want to dive in, I want to help out. And so we're also seeing around 12,000 daily downloads of koalas. So again, just more on the status of koalas. So like I said, bi-weekly releases, very active community with daily changes. So the most common functionality, so Pandas, right, it's a very large API set, right? There's a lot of different functionality that you can do with Pandas. Not all of it yet can you do with koalas, right? So the most common functions have been implemented. So around 60% of the data frame and series API functionality APIs have been converted to Koalas, and 60% of the data frame, like group bys APIs, have been ported over, and only 15% of like the index and multi-index APIs and things like that. So it's going to take some time for all the functionality of Pandas to be brought over to Koalas, but it's a pretty good amount of functionality that we have now. So how to get started? So you can just do a pip install Koalas, and that's all you need to do. But you do need to make sure that, right, if you're going to run Koalas, you need to have PySpark as well, right? Because it's Koalas on top of Spark. You could also do a conda install Koalas, and there's more instructions here on our GitHub. Also, there's a documentation that you can go ahead and read through. And like I talked about before, the Databricks Community Edition, again, it is a free community edition that anybody can sign up. You get a single node that you can develop on and with, and then Koalas is already installed there. So it's just something so that you can learn and play. Also, I strive, let everybody know to get involved. So there's a lot of different ways that you can get involved in this project. It's not just contributing to the code or making a pull request, which is awesome, but also, test it out, be a tester. That's a way to contribute. Contribute to documentation, file JIRAs, file feature requests, answer questions that people have. I mean, those are all ways that you can get involved with the community and contribute without necessarily having to submit code. But that's great too. So this talk, the notebooks and slides, you can actually find on my GitHub, which is github.com, Amanda Moran, PyData NYC, or you can just scan this QR code there. So I'll leave that up. So thank you very much. I appreciate all of your time today. And if we have any time for questions, I'm happy to take those.
Thank you, Amanda. Please put your hand up if you have a question. We'll get you a microphone so we can get it recorded.
Hey, so this was announced at the end of April, you said?
That's right.
How much time previous to that was spent internally developing it? Or was that the start of the project, was April?
No, they developed the project for, actually I'm not quite sure on the timeline. I think it was around a year or so, give or take. And then once they kind of got a good portion of it, a good chunk, that they could actually donate it out. Yeah, good question.
Hi, thank you. This is really interesting. So I'm wondering, a lot of times projects like this that are an abstraction layer around a more close to the metal tool, you lose quite a bit of efficiency. So do you know, I know it is probably going to vary based on what you're doing, but do you have some sense on how using this versus using PySpark directly affects the efficiency?
Yeah, so that's a great question and a good thought to have. I have not heard of any, because it was built by the folks who built PySpark, so they know those custom connections to make sure that you're not losing that from one to the other. And so actually, I didn't show it here, but I do have some slides on how that Koalas data frame underneath, at the end of the day, really is a PySpark data frame. So they just have a one-to-one mapping, so to speak, under the hood.
Okay, thanks.
Thank you.
Hey, great talk. I have a question about package management for a more traditional kind of PySpark clusters. Does this require a cluster-side installation of the Koala library? Or what can you tell us about the dependencies that will be needed on top of PySpark?
So there should be no other dependency other than, good question, other than just Koalas. Koalas, and then so with Koalas would come Pandas, right, and NumPy, I believe. But I don't think that you need to have many other dependencies other than just Koalas on top of PySpark.
Do you need that on cluster side too, or just on the driver?
I believe you'll need it on all the nodes. Yeah, yeah, good question.
Thanks, interesting talk. So I guess the ultimate test of how easy this is to use. So if I have a lot of Pandas code, and at the beginning I import Pandas as PD, Can I simply import Koalas as PD and the rest of the code works?
That's the idea. Yeah, like I said, not everything has been one-to-one mapped, right? Like I said, so if you have something that's not, that we haven't implemented yet on Koalas, it's possible that it would break there. But other than that, it shouldn't.
So that's one way to find out.
Yeah, pretty much. Yeah. And then file a bug request, right? File a JIRA.
Thank you. Related to the question before, I was looking through the library while you were talking, and I saw that there was some SQL functionality that was implemented. So I was curious what kind of overhead is incurred, or what was the motivation for re-implementing some SQL functionality versus just using Spark SQL?
So it's really about the API, so that you don't necessarily have to use the Pandas, or pardon me, the Python API. So customers, they've requested and asked for being able to use this with other languages, right? And so that's an example of that, yeah.
So I don't know if you're familiar with Dask, but it's very similar in the sense that it's trying to get a data frame and put it in a distributed cluster or something like that. They are also trying to replicate kind of the Pandas API for clusters. And one of the problems they have, since you get a big data frame, put it into a cluster, you need to partition it and distribute it. So all the operations related to sorting, so let's say a simple sorting of a column, it's quite complicated because then you need to do it multiple times and then like recursively done. Did you guys already address this somehow? I see that it's probably the 40% that is not implemented is in that area. Can you provide a bit more insight on that?
Well, I guess if I understand your question correctly, I mean, those types of functionalities are already taken care of through Apache Spark, right?
So they are just delegated to the Apache Spark.
Exactly, yeah. So like I said before, the Koalas data frame is really just an abstraction layer on top of the PySpark data frame. So any operation that you're then performing goes in directly into Apache Spark and is run there. So that is made for distributed computing.
So the idea inside the organization is to make it 100% compatible, like every single instruction, or 90, high 90s?
I think it's whatever, we get requested. People run stuff and say, oh, okay, hey, I need this. I think the idea is it to be a community-driven, user-driven, whatever it is that they need. But that's the ultimate idea. But I think the team of engineers who works on it is only around eight or nine. So it's a lot of functionality to port over. But I think that is the plan.
Okay, thank you.
I think we have time for one more question. Getting my steps in.
Hi, Kenny. Nice to meet you. So that wasn't being ran in Jupyter, right? Can this be ran in Jupyter?
Yes.
Okay, cool.
So actually, so with Databricks, you can actually export any of the Databricks notebooks as a Jupyter notebook. So that's what I've done. I've exported it, and that's what I put on GitHub. So it's the Jupyter version of it.
Cool.
And I have done that test where I've imported a Jupyter, because you can also import a Jupyter notebook into a Databricks notebook.
Awesome.
And so I've tested that you can go back and forth. It's not just a selling point. You really can.
I was going to ask about that too. That was my next question,
Okay.
kind of about what Databricks was. So, cool.
Perfect.
Thanks.
Sure.
All right, thank you, everyone.
Thank
you,
you.
Amanda. Let's give her a round of applause.